Hi, Al Williams with Hackaday here. I just finished working on the mBed based pocket signal generator, and I wanted to show you how easy it is to use the TTI Wave Manager Pro software to create arbitrary waveforms for it. Now, you don't have to use this software because it just takes a bunch of data files, but it is very convenient, and it's a free download from the TTI website, although you do have to register in order to download it. It's a Windows program. I'm running it under Wine. And when you first start it up, you'll get this error, unable to read from GPIB dynamic link library. That's okay. We're not going to be talking to any real instruments, and it just is telling us it can't find any, and that's fine. But you start up with a pretty bland looking window here. I'm going to do a File, New, and that gives me some little oscilloscope looking thing. And I'm going to start off with something really simple. I'll go to Waveform, and I'll tell it I want a sine wave. But you can see you can do lots of different things, right? So I'll do a sine wave, and it says, well, you need to give it a title, and I'll call it sine 2. The amplitude I don't think really matters much because we're going to normalize it to where it all goes from -1 to 1 anyway. But since we have a 16-bit sample, I'm going to go ahead and put 65,535 here. And then on the length, for this particular project I'm working on, 16,384. There's that many samples going across the horizontal axis. So I'm going to put that in as the length. And when I do that, then I get the little sine wave generation box. And it says, well, where do you want to start? Where do you want to end? What amplitude do you want? And so I want a full amplitude all the way across. And just for variety, let's say I want 2 cycles instead of 1 cycle. And so when you hit OK, you get the 2 cycles. Now clearly we could have given it different start and ends, and there's little cursor buttons here. We'll look at that in just a second. But we've got a sine wave. Nothing you couldn't have done in Excel, but very convenient. So now this is the trick. I'm going to go to Save As, Normalized. And I'm going to call this sine 2 NRM, which is the normalized format. So it's going to change that to be -1 down here, 1 here, and 0 here. And you can see it even changed that on the axis labels. So if I look at where I saved that file, I have a file called sine 2 NRM here, and it's just, as you'd expect, floating point values that represent the sine wave, or sine waves in this case. So I've got a shell script here called terminal, and it's just a call to pick a COM 57600 baud, and it uses ASCII exfer to transfer files over to the board. So let's start that up. I have the board running. Just to make sure, I'm going to give it a question mark, which lets it print out the help. And what we want here is the load floating command. That's F. It wants me to transfer that file, so I'm going to type Control A, Control S, and then I'm going to say sine2.nrm. Now, this is going to take a few seconds because it's a lot of data. You don't have to use Pick-a-Com. You could use any terminal program you want that can just send an ASCII file up. So that could be CuteCom, or if you're under Windows, it could be whatever you want to use under Windows. Putty, or there's a lot of choices. And there it's done. Now we don't have a time base set because that was just an NRM file. So I'm going to set the time base to 20 microseconds, let's say. The curve fit does pretty well, although obviously the lower you get, the bigger the error is, since the error is pretty constant. It's a bigger percentage error. And so 20 microseconds isn't bad. And the other thing I'd like to do is I'd like to write it out to the SD card, so if we want to do this again, I don't have to do it that big long load again. And so I will write to the SD card, and I will call it sine2.cfg. And the CFG format saves the time base and some version information and things like that, and it also saves all that data. Now the data is now an integer format, so the floating point load, part of what it does is it converts it to an integer. And so when we press the G key here to go, we'll get a trace on the scope. So I'll switch over and I'll say scope snap to sine 2 PNG, let's say. That'll actually read the data from the scope so you can see what it looks like. And sure enough, that pretty much looks like the TTI waveform editor. You can see there, sine wave, not very exciting. So let's look at something a little more interesting. I've started a new sine wave here. It's the same as before, and I'll show you why I started it separately in a second. But there's a lot of interesting things on the waveform menu. I could have made triangles or squares or sync pulses or EKG or random noise. There's also this expression calculator here, which is very interesting, and especially because you got the library here, which has all sorts of things, sawtooths and noisy square waves and AM sine waves and FM sine waves and frequency shift keying modulation, and anything that you can work up some mathematical expression for, you could put in here. I'm going to cancel out of that for now. You can also just randomly draw things if you're handy enough with a mouse, so you could just draw an arbitrary waveform if you wanted to. But I'm going to do something a little simpler. I'm going to go select some of this sine wave here. You can see the little arrows up at the top. I'm dragging them. And so now whatever I do is only going to affect that non-red area of the screen. And I'm going to go back to the expressions. And here's why I didn't leave it normalized, is even though it was saying -1 and 1 here on the left edge, it really still is 0 to 32,766 here. And so if you go in and put, 0.5, that's going to draw a line way down here. And what I really wanted was a line somewhere up here. So I'll just say the amplitude is going to be something like 16,000. That should be about right. Let's see what it looks like. And yeah, kind of just chopped off that square or that sine wave there. So just to give you another quick look at something, if I go back to the terminal here and I'm going to reset the board, if I wanted to go back to sine 2, I can do a read from the SD card. And by the way, I can hit the question mark here and see what all's on my card. And I'll tell it I want sine 2 config. And you notice that was almost instantaneous. And it's got the right time base value and everything in it. So it's very, very fast compared to loading it from the serial. And when I do a go, I'm back to having the two sines back on there. When you first reset the board, incidentally, it actually zaps the memory so that you get a repeating pattern. So if you don't do anything different, you're just going to get a square wave out, or as close to a square wave as you can get. So if I'll set the time base to say, we'll just do 20 again, and I haven't loaded anything out of the SD card or from the computer, and I do a go command, I'm going to get a fairly fast square wave. And I'll show you what that looks like. We'll load that from the scope. And of course, naturally, they didn't line up on the gradical, but you can see that's a 20 microsecond, and that's about a gradical across there. So each step coming out of the buffer is 20 microseconds. And again, that's because of the calibration curve fit that I discussed in the post. So that's pretty much it. You can do a lot with the TTI software. I won't download them all, but just to give you some ideas, if I were to go make, say, a cardiac, I'll just take the default parameters there. You get that little waveform that reproduces nicely. If I were to go, say, do a sync pulse, which has a lot of different things. The expressions are, like I say, a lot of interesting expressions in the library that you can look at. So it's a pretty cool piece of software for free. Works very well with the pocket signal generator. Also works with some of the other signal generators I have around the lab. So it's a pretty good tool to have, and works a lot better than some of the cheap stuff that you might have got off of eBay that has some bad Windows software with it. This is a pretty good upgrade for that. It doesn't cost anything. Anyway, thanks for watching.